Oh, it's cold in here. Ooh, don't we all love that click? The click of the thermostat relay on our fan center relay, closing the circuit, powering our safety circuit, our limit switches, our vent damper, and then sending 24 volts to our gas valve. As long as it's on, we will have ignition. What's going on, ladies and gentlemen? Thank you so much for tuning in. It took quite some time for me to understand what is actually going on with this standing pilot ignition system. It took some time. I was intimidated by this. The schematic, wiring diagram, the ladder wiring diagrams. But once I connected the dots and followed the flow of electricity, it was quite simple. In today's video, we're going to talk about how the standing pilot gas valve operates, the purpose of the thermocouple, the pilot burner assembly, the pilot tubing, and what gas pressures all this needs to be to by hooking up our test ports to a digital manometer. If you find this video helpful, I would appreciate your thoughts and feedback in the comment section down below. And don't forget to subscribe so I could get some love from the community and continue to post more educational videos just like the one you're about to watch. Let's go. All right, let's quickly identify some of the parts here that you're going to see on the systems that you're working on. The main character of the show, that is our standing pilot gas valve. This one is made by Resideo, also known as Honeywell. There's a few other key players out there like White Rogers Emerson, Robert Shaw, to name a few. I think there's only actually 3 real manufacturers: Honeywell, Robert Rogers Emerson, and Shaw. But nonetheless, they all operate in the same fashion. Connected to our gas valve, we have this copper-looking piece of wire or tubing. We have this silver-looking tubing. We have our inlet piping, our outlet piping, and we're going to have essentially 2 wires at the end of the day. Disregard the black nipples with the ball valves coming out of the gas valve. This is strictly for testing purposes, so we can test our pressures with a manometer. Now, let's talk about theory of operation. How does this work? This copper-looking wire or this copper-looking tube, this is called a thermocouple. Now, one end of the thermocouple is connected to a threaded connection on our gas valve, and the other end is sitting in our pilot flame. You can see that blue flame right there, created by a source of ignition, and it is always on. As a standing pilot, it's always on 24/7. If you blow it out, it needs to be relit. It's not going to be automatically relit on a standing pilot system. This flame plays a crucial part of the whole action and the order of operation. The blue flame sitting in that thermocouple is being heated and is creating approximately 30 millivolts. Not 30 volts, 30 MV approximately. And as that flame heats that tip, that small electrical charge is being produced and it's being carried across this little copper wire and is being connected to the gas valve. Now, let's just put this to pilot for a second, okay? Our red plunger, your color may vary, but I can fully depress this, right? If I'm not on pilot, let's say I'm right there, I can't push it down. So this is a safety mechanism. Don't use any tools or force, hammer or anything to force this down. It's not gonna help. But let's talk about how this works. When the pilot is out and you're relighting, the instructions tell you need to make sure that the knob, the control dial is set to pilot, and you're gonna hold down the plunger. And when you hold down the plunger, you're allowing the flow of gas to pass through the internal mechanism of the gas valve, which we're gonna call the pilot valve of the gas valve. And that gas is gonna flow through the gas control valve, through the pilot burner outlet tapping, through inside that silver tubing and end up at that little hood-looking thing, which is called a pilot burner. When you spark that, you create the flame, and while you're holding this down, you're manually holding open the gas valve solenoid. Okay? That 30 millivolt charge being produced by the flame carried through the thermocouple. When I let go of my plunger, that 30 millivolt current is going to keep the valve open by means of electricity. There's basically essentially a magnet inside there. When I'm pushing this down, I am forcing that magnet down, and the electrical charge is going to capture that magnet and hold it open. So when I blow out this flame, or there's a gust of wind, or the gas service is interrupted, shortly thereafter, the flow of gas is going to stop at the gas valve because you can hear that click. And watch this, ladies and gentlemen. I blew out the flame. You still hear it flowing. Let's give it about 7 seconds. You can hear it click. There's that click. And what just happened there, ladies and gentlemen, is the electrical charge slowly decreased, and once enough current wasn't generated, the magnet was released and it closed the pilot valve on the gas valve itself. Now, gusts of wind interrupted an interruption of gas service is one of the reasons pilots go out. However, the major contributing factor for pilot outage on a standing pilot system is wear and tear. As that tip sits in that flame 24 hours a day, 7 days a week, 365 days a year, wear and tear takes over. And that tip can be distorted, bend out of place, start to corrode, and no longer be able to produce those approximately 30 millivolts of power that's going to carry through the copper tubing, the wire, and holding the gas valve open. Quite simple. It's a very, very simple design, strictly mechanical. You don't need any power to keep the pilot valve open. None whatsoever. We do need power in this particular standing pilot gas valve in order to have main burners open. All right, so we just relit our pilot. We're holding down the plunger on the standing pilot gas valve. So when we're holding this down, usually around 60 seconds, we're allowing some time to pass, and we're allowing the tip of the thermocouple to be heated by the pilot flame so it can generate that small millivolt amount of current to flow through the copper wire, which is then going to be responsible for holding open the solenoid valve on the pilot valve side of the gas valve. Make sense? Right now, that tip of the thermocouple is sitting in the flame. That flame and the reaction to that metal is creating approximately 30 millivolts of power. Okay? That power is being transferred through this little copper wire. And inside here, that small amount of electricity is holding open a magnet, right? That magnet, right now, I'm manually holding down by holding the plunger. So when I let go of that, if there's power there, holding that magnet open, our pilot valve is going to stay on, and the gas is going to continue to flow through the pilot valve to the pilot burner. Make sense? If not, email me, Mike at MikeyPipes.com. We can do a one-on-one consult, and we can take things a little bit further and give you some more one-on-one education. Some of us learn by opening a book. Some of us learn by doing it. And some of us learn by repetitiveness over and over and over again until we can drill it into our head. But the objective here is that we can all learn how this works to save you some time in the field or even troubleshooting your own machine at home. It's a little cold in here. Let's crank up the thermostat. So the next time you hear that click, you're going to know exactly what that click came from. It came from the thermostat relay on our fan center relay assembly, which consists of a 24-volt transformer, that relay, and it allows for burner operation. On our next video, we're going to talk about the wiring diagram behind all this and how this works. How the order of operation, when there's a call for heat, how the thermostat relay, why it clicks, how it sends power to your vent damper, and the safety circuit consisting of your rollout switch, your low water cutoff, your spill switch, and transferring power 24 volts to the gas valve. So stick around, make sure you hit that thumbs up button, subscribe if you haven't done so already, and hit that notification bell to get post notifications, because when I drop this video, we're all gonna learn something new that day. Thank you so much for watching. Until next time, be well, God bless, stay safe.